All right, so standard six is all about measures of location. And this is just kind of a term I use for z-scores and percentiles. Because both the z-scores and percentiles are just about like where your data is in relation to everybody else. So it's the relative location of a single data value, right, in a set. So for z-scores and percentiles, let's see. The dataset below depicts the points per game for an NBA team in 15 randomly selected games. Calculate and interpret the z-score for a game where the team scores 99 points. Calculate and interpret the percentile for a game where the team scores 99 points. So the z-score formula will be provided for you on a quiz or a test. You are expected to know how to calculate a percentile. Go ahead and try these problems if you'd like. You can pause the video. When you're ready to see the answer, you can just hit play. Okay, so for the z-score is the value that you are observing minus the mean divided by the standard deviation. So we do need to calculate the mean and standard deviation for this data set. So you can put the data in L1 in your calculator and then have it spit out the mean and standard deviation. The mean is the x bar, the standard deviation is the s sub x. So we end up with a mean of 95.6 and a standard deviation of 12.437. So value is 99 because that's the number of points in the game that we were curious about. 99 minus 95.6 divided by 12.437 gives you a z-score of 0.273. So what is a z-score? A z-score is the number of standard deviations you are above or below the mean. So if I told you that you took a test and you got a z-score of 2, that would be very, very good because you were 2 whole standard deviations above the mean in the class, right? Or if I told you that you went golfing and your z-score was negative 3.18 in terms of your golf score, you'd be thrilled because that means that your golf score was 3.18 standard deviations less than the mean, and it's better to have a low score in golf. So in this context, 99 points is 0.273 standard deviations above the mean number of points scored. And that is my interpretation. So calculating the z-score is one thing, but you do need the interpretation in order to receive full credit. And the same goes for the percentile. So a percentile is just where you are in a data set. So for example, if I told you that you were in the 99th percentile for a test grade, that would mean that you scored better than 99% of people, which would be very, very good. If I told you that you were in the 30th percentile for a test score, then you scored better than 30% of people, which is still good, but maybe not where you want to be. So calculate and interpret the percentile for a game where the team scores 99 points. So what you're doing is you're looking at the original data set, right? You're actually looking at the data values themselves. And you're just looking for where 99 is in that data set. And if you count, it is the 99 points is the 10th number when you order it from least to greatest. It's the 10th number out of all 15 numbers. So 10 divided by 15 will give you 0.6 repeating. Multiply that by 100 just to get it to a whole number, and we end up with roughly the 67th percentile. So scoring 99 points is more than 67% of points scored in games by this team, based on the data set. So that is z-scores and percentiles. Two separate but very similar measures of location. And that's standard 6.